Today, in this lesson, we will review the indirect methods for carbon sequestration and accounting.
Indirect methods assess biomass through ancillary variables. These indirect methods generally do not require field sampling if the models and equations are ready to use and not to be generated. Indirect measurements of forest carbon stocks are based on calibrated relationship with field measurements. Among the different ways to estimate carbon using biomass equations is by means of the dry weight. In this sense, weight can be interpreted as an estimation of the wood volume. Therefore, it's important to know density of the wood and its relationship to water. This is known as the specific gravity of wood. Knowing the dry weight of our wood, the conversion to carbon can be easily obtained by applying the carbon fraction of the wood. Another indirect method is the application of biomass equations. Biomass equations are a type of allometric equation that relate morphologic metrics with biomass for different parts of the tree. They can be applied with indirect available sources, such as inventories data. There are two main types of biomass equations: the generalized biomass equations that relate the biomass to only one parameter, frequently the diameter at the breast height. Additive biomass equations, where the total biomass of the tree is obtained by aggregation of individual parts of the components. Another method is predictive models. The predictive models use existing data and knowledge of forest growth and biomass production to create projections or scenarios of biomass production and carbon sequestration in the future under different forest management practices or policies. In addition, predictive models are used to evaluate carbon sequestration potential in a planned project. The advantages of predictive models are that for a particular project, they offer more precision when parameterized, reflecting local conditions. Moreover, predictive model use have increased due to their capability to reflect changing management regimes and climate scenarios. On the other hand, the disadvantages of the predictive models can be their use or applicability, when models are not implemented with the user interface area. Moreover, models are process-based models have high data requirements to parameterize all processes involved and can be very demanding in terms of computing power. Examples of predictive models, or the more popular ones, can be the Co2 Fixed Models. The Co2 Fixed Model is a stand-level simulation model which quantifies the carbon stocks and fluxes in the forest biomass, the organic matter, and the wood products. The carbon budget model of the Canadian forest sector is applied as a stand and landscape level model of forest ecosystem and carbon dynamics. Another popular model is the Terrestrial ecosystem model. This is a process-based global-scale ecosystem model which estimates carbon and nitrogen fluxes and pool sizes in terrestrial ecosystems at a multi-time step using spatial information on climate, soil, vegetation, and land use. Finally, another method to estimate indirectly biomass and carbon is remote sensing in GIS. Remote sensing is a process of acquiring data from a distant object without being in contact with it. Currently, there are three main technologies that can contribute to improve biomass estimates. First is the long wavelength radar instrument, or synthetic aperture radar, SAR, which is used where biomass is understood as an interpretation of the backscatter signal. Next, we have airborne LiDAR systems and polarimetric SAR interferometry, where imaging LiDAR-derived vegetation height maps can be used to generate biomass maps, or we can measure forest height and apply local or regional allometric relationships to estimate biomass. Finally, we have optical methods or optical data, such as Landsats, MODIS, MERIS, and SPOT. These methods are reviewed in detail in other MOOCs generated by the MaiL project. For more information, please check them. Moreover, if you are more interested in studying anything of the points referred before, please check the reference. Thank you for your attention. Please, if you have any doubt, don't hesitate on emailing me.